RET Program 2021, Project Number 2, a Robots Positioning System, Development and its Applications, University of Cincinnati, National Science Foundation. Hi, my name is Robert Fritz. I teach at LaSalle High School, and I'm from Cincinnati, Ohio.
My name is Paul Makowitz. I teach at Holmes High School in Covington, Kentucky. In our research and presentation, we'll use the engineering design process. Our research training started with Python coding, which is a programming language to program information into microprocessors for use.
After we coded Python, we then programmed a piece called Raspberry Pi, which is a CPU. The Raspberry Pi was then used in conjunction with UWB sensors, which would measure the distance of the robot.
Our research had to deal with sensor positioning, so setting up anchors around a space so that they can determine the best way to catch a moving object or a tag and finding its location.
After coding Python and connecting it to Raspberry Pi and the sensors, we use a system called trilateration. Trilateration is where points A, B, and C are all triangulated, which would tell us that the robot is at point D. This is called positioning. When we look at it on the graph, you can see the graph shows the distance measurement from all three sensors.
Because of the error in trilateration, there were developed things called filters. These filters are used to zero in on the exact location. In our research, we used two, moving average and Kalman. The moving average is taking an average of the first 30 or so data sets, and then from there, as you add a data point, you get an average of the whole data. The Kalman takes a prediction of a single point, and then from there, using that prediction and the error in the measurement, creates a representation of the true distance. From the graphs, you can see the green is moving average, and the red is Kalman, and Kalman is more exact. My unit is called Modeling Functions for Use. What it's going to do is we're going to use the data that we got from determining the position of something, and we're going to use it to determine the position of a camera in the school. Using that position, students will write functions to model that camera location.
My unit is going to use autonomous robots and parabolic curves. My students are going to build launchers, which we're going to launch what's called a data bot, and then we're going to graph and discover the equations that deal with parabolic curves.